Hey guys, we're going to look at long division for polynomials, and we're going to start with long division for numbers, which we've done a while ago, so let's refresh our memory on that. I'm going to do the 72,860 divided by 3. So, yeah, this is supposed to be a division sign. All right, so I'm asking myself, how many times does 3 go into 7? And 3 goes into 7 twice, so I'm going to do a 2 times 3 is 6. All right, and then after that, I'm going to subtract. So 7 minus 6 is 1. All right, so then I'm going to bring down my next number and pretty much do the same thing again. I'm trying to figure out 3 goes into 12 how many times, and it goes in 4 times. So then I do a 4 times 3 for a 12, and then I subtract, and I'm putting this in color for a reason later. All right, so that subtracts to 0. So then I'm going to, all right, I'm going to bring down my next digit, which in this case was an 8. So how many times does 3 go into 8? And 3 goes into 8 twice. So I do 2 times 3, which is 6. Put this in my color here. So the 2 times 3 is 6, and then I will subtract. All right, next digit is a 6. So let's see. 3 goes into 26 8 times. 8 times 3 is a 24. So then I will subtract. And 26 minus 24 is 2. And then I've got one last digit left. I've got the 0. So how many times does 3 go into 20? So 3 goes into 20 6 times. 6 times 3 is 18. So I'm going to put that under there and subtract yet again. So my 20 minus 18 is 2. Okay, so what this means is this number up here is my quotient, the 24,286. And then the remainder is what I have at the bottom here. So this 2 is my remainder. And the divisor is what I was dividing by. I was dividing by 3. Okay, so my final answer is going to be the quotient plus the remainder over the divisor. A lot of times we say 24,286 and 2/3, or you can just write 24,286 plus the 2/3. So this is my final answer. All right, now let's see if we can apply that to polynomials. So what I am dividing by goes outside of this division, so I'm going to have my x squared plus 3x plus 2 on the outside, and I've got the 2x to the 4th plus 3x cubed. I've got a plus 5x and a minus 1. Now I left a gap here for a reason. I should hit every exponent on my way down. I have an exponent of 4 and then 3, and then I've got an exponent of 1. I kind of skipped the 2. So I'm going to say that there are 0 of the x squareds. So I've hit every exponent on my way down. I kind of have a placeholder for each of them. So now I'm going to try to follow what I was doing over here for our numbers. I was looking at the beginning, how many times does 3 go into 7? And 3 goes into 7 twice, but I was just looking at the 7. I was just looking at that first number. And in this case, I'm just going to look at the first term, the 2x to the 4th, and the x squared. Okay, so how many times does x squared go into 2x to the 4th? Like, what can I multiply the x squared by to get the 2x to the 4th? Now, because this is a 1x squared, I know that 1 times 2 gives me the 2. Let's see about the x to the 4th. X squared times x squared is x to the 4th. So I end up with a 2x squared. All right, so now I'm going to distribute this 2x squared to each of these terms. So 2x squared times x squared is 2x to the 4th. My 2x squared times 3x gets me up to a 6x to the third. And 2x squared times 2 gives me a 4x squared. Okay. Now I'm going to do, again, what I was doing over here. I subtracted. So I'm going to subtract all this blue stuff. The whole polynomial gets subtracted from what was above it. So, I mean, 2 minus 2 is 0. I have 0 of the x to the fourths. My x cubes, I've got 3 minus 6. All right, so my 3 minus 6 is negative 3. And I still have the x cubed, negative 3x cubed. And then again, don't forget you're subtracting. I'm doing 0 minus 4, not 0 plus 4. So keep in mind of this subtraction here. So 0 minus 4 gives me a negative 4. So negative 4x squared. And then I will bring down what's left, the 5x. Put this in purple here. Bring down my positive 5x and my negative 1. All right, so that's pretty much the same process I did with just the numbers. And I had to do the same process over and over and over again, which is what I have to do here as well. So now I am looking at the x squared and the negative 3x. So x squared needs to be multiplied by a negative 3 and an x. All right, so now I'm going to move on to my next step where I distribute. So negative 3x times x squared is a negative 3x cubed. My negative 3x times positive 3x is a negative 9x squared. And my negative 3x times 2 is a negative 6x. Okay, so I distributed. Next up, I have to subtract this whole thing. All right, so anything minus itself is 0, which is good. That was kind of the whole point. And then I've got to deal with the negative 4x squared minus a negative 9x squared. Whenever I minus a negative, it's going to turn into addition. So it's like negative 4 plus 9, so a 5x squared. All right, and I'm going to have to write over this. I'm going to look at my x's here. Again, I'm subtracting. So a 5 minus negative 6 is like 5 plus 6. So I'm going to positive 11x. And then I will bring down the negative 1. And then we do this all again. So if I compare the x squared to the 5x squared, it looks like I have to multiply by just the number 5. All right. And then next up, I will distribute that 5 to each of these terms. I get a 5x squared, a 15x, and a 10. All right, and then I need to subtract this whole polynomial. 5x squared minus 5x squared, anything minus itself is 0. So that one's gone. And then again, keep in mind you are subtracting. 11 minus 15 is a negative 4, so negative 4x. And negative 1 minus 10 is a negative 11. All right, and I know I'm done because the degree on this, the exponent, is like x to the first. The degree is 1, which is less than this x squared. So as soon as the degree down here is less than what you were dividing by, then you know you can stop there. All right, so I'm going to put in green here my quotient, which is a polynomial 2x squared minus 3x plus 5. The remainder, I'm going to have to put this over here. The remainder is what I have at the bottom, so negative 4x minus 11. And the divisor was what I was dividing by right here. So in this case, the x squared plus 3x plus 2. All right, so my final answer is going to be like I did with the long division. I'm going to do my quotient plus the remainder, in our case, negative 4x minus 11, over the divisor. So x squared plus 3x plus 2. So here's our final answer. All right, and the nice thing is we can check our answer. It's messy, but we can check our answer. So as for the just numbers here, I want to know if instead of dividing, if I multiply this 24,286, if I multiply it times 3, and then I add this 2 on, it should, if I did it right, it should give me this 72,860. So let's see here. All right, so the 24,286 times 3, and then I add on the remainder 2, and yeah, I got the 72,860. So yeah, you can tell we did it right. And I'm going to use that same idea, but on a polynomial. So I'm going to multiply these polynomials. It's going to require a lot of distributing. And then I'm going to add on the remainder, the negative 4x minus 11. Okay, so distributing. I got to multiply the 2x squared times each of these. So I get 2x to the 4th plus 6x to the 3rd plus 4x squared. Okay. Now I need to distribute my negative 3x to, again, each of those three terms. So negative 3x times x squared is a negative 3x cubed. Negative 3x times a positive 3x is a negative 9x squared. And negative 3x times 2 is a negative 6x. All right, so we distributed two of them. Now we got to distribute the 5. So I get a 5x squared, a 15x, and a 10. Now, again, that was me doing all that multiplying, and then I'm going to put plus the remainder at the end here. So plus the negative 4x, which if I'm adding a negative, I can just say subtract. So minus a 4x and then minus 11. Really long, but I'm going to combine my like terms and see if it gets me back to where I started. So as far as my x to the 4ths go, I've got a 2x to the 4th, and I don't see any other x to the 4ths. All right, so I'll just leave it 2x to the 4th. All right, x to the 3rd, let's see. I've got a 6x to the 3rd, a negative 3x to the 3rd, and those are the only ones I see. So if I combine 6 minus 3 is 3, so I'm ending up with a 3x to the 3rd. All right, this is looking good so far. Let's see if I get the rest of them. My x squareds, let's see, I've got a positive 4x squared, a negative 9x squared, positive 5x squared. All right, so let's combine these. The 4 and the 5 add up to a 9, and then you've got a negative 9, so it adds up to 0 of the x squareds. I don't really need to put 0x squared in here. I'm just going to move on to my next term. So for my plain x's, I've got a negative 6x and a 15x and a negative 4x. All right, so negative 6 plus 15 minus 4 is a positive 5, so I'm up to 5x. All right, and then the last bit is the positive 10 and negative 11, which adds up to a negative 1. All right, so because this is the same as what I was dividing up here, then this tells me, yes, I got the correct answer. All right, so let's do one more. I'm going to do the x cubed minus x squared minus 2x plus 8. All right, I did hit every exponent on the way down. That's a good sign. And it is all divided by an x minus 1. Okay, so if I just look at the first term, x times what is x cubed? So x times x squared is x cubed. And then I have to distribute the x squared. So x squared times x is x cubed. Good, that's what I wanted. And x squared times negative 1 is a negative x squared. All right, so I have to subtract all of these guys. X cubed minus x cubed, anything minus itself is 0. Negative x squared minus another negative x squared, I again have something subtracted from itself. So I get another 0. So now I'm going to have to bring down both of these other terms, the negative 2x and the 8. I can erase the 0 and kind of go back to the beginning. Now I'm wondering x times what is a negative 2x? So I've got a negative 2. And then I have to distribute that negative 2 to each of the terms. So I get negative 2 times x is a negative 2x. And negative 2 times negative 1 is a positive 2. All right, and then I subtract the whole thing. So negative 2x minus negative 2x is 0. I don't need to write the 0. I'm going to do 8 minus 2, which is 6. So I'm done. I've got the quotient plus the remainder over the divisor. Okay, so here's my final answer. And I do suggest, as far as tests and quizzes go, to check your answer and make sure you got it right before it gets graded. All right, here we go.